Hello Math 141 students, it's Professor Gina, and this video is intended to help you with your classwork for March 25th. I'm going to start by doing 3 problems that will help you with number 2 on the classwork. In these problems, we are looking at exponential equations. We use opposite functions or inverse functions of logarithms when we have something that has an exponent. So I'll take the log of both sides. The base of the log doesn't matter, we just need them to match. So I'll use base 10 because if we have to do any calculations in the calculator, that'll make it easier for us. Now the nice thing is that when we have a logarithm, we can use the exponent rule and we can bring this exponent down into the front, which is going to be helpful. So I'm going to put the 1 minus x down in the front times log of 2 equals log of 3. Now here's the important part. Log of 2 is just a number. And so I'm going to distribute it to both of the items that are in the parentheses here. So I'll have 1 times log of 2, which is just log of 2. And then I'll have minus x times the log of 2. What we're trying to do is get the x by itself. So I will subtract log 2 from both sides. And then I'm going to divide both sides by negative log 2. So I can get rid of that negative sign at the same time as I get rid of the log 2, so I can have x by itself. If I plug this into a calculator, I can get that x is approximately negative 0.584,963. On your exam, I'll have you round either 5 or 6 decimal places. So this will be our answer for this first problem. For our second problem, let's take 5 to the x power equals 4 to the x plus 1. In that first example, we only had an exponent on one side of the equation, but in this example, we have exponents on both sides. I'm going to proceed the same way I did in the first part. I'm going to take the log of both sides. So that will allow me to bring those exponents down into the front. So I'll have x times the log of 5. And then I'll have x plus 1 times the log of 4. Now, similar to the last problem, this log of 4 will be distributed to both items in the parentheses. So we'll have x times log of 4 plus log of 4. And I want to have all the x's together on the same side. So what I'll do next is I'll subtract x log 4 from both sides so that I can get all the x's onto the left. And then I'm going to have x log 5 minus x log 4 equals log 4. Now here's the important part. I want x by itself. So what I'm going to do is actually factor it out on the left-hand side. So I'll bring the x out to the front, factoring out of the 2 terms that are there. I have log 5 first and then log 4 second. And then I can divide both sides by, oops, what happened? I can divide both sides by this whole quantity, log 5 minus log 4. This is just a number. Even though it looks really big, it's just a huge number. And that'll be my answer for x. This is the exact answer. If I plug this into a calculator, I would get 6.212,567. So again, this is the exact answer. This is the approximate answer. Whenever we enter something into a calculator and we cut off part of the decimal, that's the approximate answer. For our third example, we're going to solve an equation that has exponents in but looks a little bit more complicated. So e to the 2x minus e to the x minus 6 equals 0. This is actually a quadratic equation sort of in disguise. I'm going to do a variable exchange. I'm going to let m equal e to the x. We had a couple of examples like this a few weeks back in class, and we always looked at whatever the middle term was, and that's what we let the variable equal when we were doing some kind of an exchange. So rewriting this is this is e to the x power squared, or using our new variable, m squared minus m minus 6 equals 0. Well, that's nice because this is something that we know how to solve. We can factor this into m minus 3, m plus 2, and we get two solutions. M is either equal to 3 or m is equal to negative 2. So now we have to go back and substitute back for our original. E to the x is equal to 3, or e to the x is equal to negative 2. So these now look more like the equations we were solving before, like number 1, where we're going to change to logs. When I have e as my base, I want to use the natural log, because natural log has a base of e. So natural log of e to the x equals natural log of 3, or natural log of e to the x equals natural log of negative 2. Okay, so here's my two options. On the left-hand side, we have an identity. The identity is, I'll write it over here, that whenever I have natural log of e to the x, that just equals x. So I'm going to say that this part is just x equals natural log of 3, or x is approximately 1.098612 using a calculator. On the right side, I have x is equal to the natural log of negative 2, but this is illegal. We're not allowed to plug in a negative number for a log, so we'll say that this is not possible. So for this example, we have one answer, and it's that.